Okay, in today's lesson, we're going to start looking at sequences, and then we'll focus on a specific type of sequence. So we need to get used to some of the terminology. First of all, a sequence is a list of numbers in a specific order or pattern. And each number or term in the sequence corresponds with the position number that locates it in the list. And I'll explain more of that in just a second. So it says that you can write the sequence as a function where the domain is 1, 2, 3, 4, and that is representing like the position that you're in the sequence. And the range is going to be the set of numbers or the terms that are in the list. So for example, we can have two different types of sequences. We can have finite sequences or we can have infinite sequences. So a finite sequence will stop. They'll give you a list of numbers, but there's a stopping point. An infinite sequence is going to continue on forever. So for example, if I say 2, 4, 6, 8, and then I stop, then that's a finite sequence. There are 4 spots, and in those 4 spots, there's a 2, there's a 4, there's a 6, and there's an 8. Now if I look at the infinite sequence, they're putting the ... telling me that we're going to continue on with that pattern. Okay? Another sequence. So I can say 1, 4, 9, 16, 25. That's a finite sequence because I have stopped. The infinite is continuing on. And so some of these sequences, you guys will see patterns. So for example, they're multiples of 2. All right? The next example, maybe you realize that those are perfect squares. So you guys are going to start focusing on certain types of sequences. So on this particular problem, I say write the sequence, state the domain, and the range. So remember the domain is the position number, okay, or the input, and then the range is the term, which is going to be like our output. So if I take a look at this first example, I can see that in the first spot is a 3. So I'll write a 3. This is saying in the second spot, you're going to put a 5. In the third spot, you're going to put a 7. In the fourth spot, you're going to put a 9. Okay, so the domain is I had a first, second, third, and fourth spot. And in the first spot was a 3, and in the second spot was a 5. Then in the third spot was a 7, and the fourth spot was a 9. Okay, over here, I'm saying in the first spot there's a -3, second spot there's going to be a 6, third spot there's going to be a -12, and then continuing on, fourth spot's a 24, and then the fifth spot's -48, and then again they're going to continue on. So whenever I write my domain, I just want to include those ... which tells me that example B is an infinite sequence, and then example A is a finite sequence. All right, so let's take a look at the graphs of sequences. Whenever you graph these, they should be discrete, and what that means is they should just be individually plotted points. You're not going to connect the lines. So if I say let's graph the sequence, and they give me 5, 10, 15, 20, 25, I can write that as ordered pairs. So remember that the n, okay, is the position number. So in the first spot, my term is a 5. So I can plot 1, 5. In the second spot, I have a term of 10. In the third spot, I have a 15. And in the fourth spot, I've got a 20. And then in the fifth spot, I have a 25. And again, these should just be individually plotted points. So now plot each of your points. Plot 1, 5, 2, 10, 3, 15, 4, 20, and then 5, 25. Do not connect your dots. And then again, you're going to state your domain. So the domain is the position numbers. So there was a first spot, a second, a third, a fourth, and a fifth spot, and it was finite, so I don't need the ... And then the range is the term or the number that's actually in that spot. So in the first spot there was the 5, then it was the 10, the 15, the 20, and then the 25. Okay, so again, these should be just individually plotted points. All right, so then other examples will be, if I give you a sequence, can you predict a given term? So maybe I ask you to predict the next term, or maybe I ask you to predict the term that's like 5 spots down the road. All right, so for example, I'll start off easier. If I give you 2, 4, 6, 8, and then you continue on, or I give you a sequence, -6, -7, -8, can you find f of 10? And so what that is saying to you is, can you figure out the term that's going to be in the 10th spot? This one is saying, can you find the term that's going to be in the 6th spot? So we'll start off with this one because it's a little bit easier. So I've got 1, 2, 3, so this would be my 4th, 5th, 6th spot. And so they are subtracting 1 every time, so that will give me a -9, -10, -11. So in the 6th spot, the term is -11. All right, on this one, I just have to go out a little bit further. I need to go out to the 10th spot. So there's already 4. So then I've got 5, 6, 7, 8, 9, 10. Okay, so 2, 4, 6, 8, keep going, 10, 12, 14, 16, 18, 20. In the 20th, or I'm sorry, in the 10th spot, I have a 20 term. The term's going to be 20. All right, so we're going to start looking more specifically at sequences that have certain names. This one for today's lesson is arithmetic sequences, and then the next section has a completely different type of sequence. So the thing to know about an arithmetic sequence, which is also known as a discrete linear function, is a sequence which has consecutive terms having a common difference. And so what that means is that they are consistently adding the same number, or they are consistently subtracting the same number. So it has to be consistent for it to be arithmetic. All right, so I'm going to give you a question saying, is the sequence arithmetic? Again, are they constantly adding the same number, or are they constantly subtracting the same number? All right, so here are my 3 examples. And so when we're looking at this, from -40 to -60, they are going down by 20. Okay, so from -60 to -80, they are going down by 20. They are going down by 20. Is that a constant value? Yes. All right, so yes, the common difference is constant. All right, looking at the next example, from -6 to 2, they are increasing by 8. From 2 to 10, they're increasing by 8. Here, we're increasing by 8. Here, we're increasing by 8 as well. So again, yes, the common difference is constant. Okay, look at the next example. So we have from -2 to 0, 0 to 2. So from -2 to 0, they are increasing by 2. Here they're increasing by 2, increasing by 2, increasing by 4. Nope. Common difference is not constant. So it's not arithmetic. We're going to start looking at actually writing rules, because if I asked you guys to predict the 2000th term, you're not going to want to write that out all the way to the 2000th spot. So we're going to come up with rules or equations to help us predict those future terms. So an explicit rule for a sequence defines the term in a position n after or as a function of n. So what that means is you're just basically coming up with an equation to predict the next number, right? So for example, if I want to write an explicit rule for the 20th term, the equation that I come up with, I can just plug a 20 in and get out the answer. A recursive rule is a little bit different because it's going to relate. So like if I want to find the next number, I have to use the previous number to do so. For example, in example A, if I want to talk about a recursive rule, I would say, okay, well, if you want to find the second position, you need to take the previous number and subtract 20. If I wanted to write an explicit rule for, like I said, like the 20th term, then I could just plug in a 20 into my rule. So again, like, I don't know how well that came across. A recursive rule, its equation tells the reader that you have to use a previous number to find the next number. An explicit rule just lets you plug in the spot that you want and you crank out your answer. So recursive rules, if you're doing them by hand, can be more time consuming because you have to expand it out. An explicit rule just lets you plug in the spot that you want and then you can calculate your answer. So the equations are going to look ugly, but since you guys get to use your notes, that's going to be pretty basic for you, and I will highlight what spots you're always going to be plugging numbers into. Here's something else that we're going to write down. So you can write different explicit and recursive rules for a sequence depending on what integer you use for the position number. So what that means is some people will say like, hey, this is the first spot, and they'll use a 1 to represent the first spot. But sometimes they'll use a 0 as their starting value. So your equations can be a little bit different depending on if they are using a 0 as the starting number or if they're using a 1 as the first number. So I've got a couple different equations dependent upon if they say a 0 or if they say a 1. All right, so for an explicit rule, if they start off, or if you start off and you're going to say, hey, well, I'm going to let 0 represent the initial starting point in the sequence, and then the next number, which would actually be the second spot, but you're now allowing that to be a 1. This is going to be the equation that you use, or this is going to be the equation that HRW uses. So you guys want to make sure that you write this down. Okay, and this is again if you're saying that 0 is the starting position, this is the rule that you're going to write down. All right. So the A represents the term that's in the very first spot, and then let me get a highlighter here real quick. The D represents the common difference. N is going to be whatever nth position they want you to find. So again, the D is the common difference. Make that a little bit, there we go. All right, so you guys will write this out. This is my explicit rule, and you're going to actually fill in what the first term is, and then you're going to fill in what the common difference is. Those are the only two spots that you're going to plug something in. Now, if they say that you're using a 1 to represent the first spot, then this is going to be your rule that you're going to use. Okay, so you're going to say f of n equals, again, A is where you're going to actually plug a number in. Then you're going to say plus whatever the common difference is. Then you're going to put parentheses and you're going to say n minus 1. Okay? And this equation and this equation are equivalent. This one, if I distribute, I have a dn. Okay? But again, there's going to be like some number here. Maybe I should just wait until we get an example. If I were to distribute this and then simplify this, it would simplify down to this rule. Okay, so these are two equivalent equations. Now, a recursive rule, like I said, talks about using a previous number. So if you have a 0 as your starting position, your rule is going to be, and you're going to write down f of 0 equals, again, you're going to plug in what that first term is. Then you're going to write down f of n equals f of n minus 1 plus, you'll put your common difference. And then you're probably going to have to fill in the inequality. Pretty sure you're on HRW it leaves this blank. This will always be one more than what they have for the value in the parenthesis here. All right. And then when I read this, so how you would read this is telling the person, hey, this is the first spot, and in the first spot there is this number. And then this f of n minus 1, if I wanted to read that to you in words, that means we'll then take the previous number and add the common difference. So that f of n minus 1 means the previous number. So f of n minus 1 reads as the previous number. All right, so this is the first spot in the sequence is this number. And then to predict any future numbers, I'm going to take the previous number plus the common difference. For n's greater than or equal to, and then whatever number this is, this number will be one more than that number. Okay. If the a is a 1, no, I'm sorry, not if the a is a 1. If the n is a 1, so if the 1 is the starting position, then the rule is going to be that f of 1 equals a. So you'll say to the reader, in the first spot, this is the number in the first spot. And then the rule for the reader will be to find the next number. You're going to take the previous number plus the common difference. So you'll plug a number in there. And again, if you guys have to fill this in, this number is always one more than what you have in the first parenthesis. So if that's a 1, that's a 2. If that's a 2, this is a 3. Okay. All right, so we're going to stop there for today, and then tomorrow I'll give you guys some more examples.